this video, we're going to talk about evaluating functions. So I have three different functions. F of x equals x squared plus 2x plus 4. G of x equals 3x minus 7. And h of x equals x squared minus 5. To evaluate a function, this number inside the parentheses represents the x value, the input value that I want to plug into my function. So I'm going to replace the x's in f with -2. So the first thing I want to write down is f of -2. And then I'm going to copy down this equation, but instead of writing the x's, I'm going to put a little parentheses for myself. So I have parentheses squared plus 2 times parentheses plus 4. And now I'm going to plug in the number that they gave me in place of x. So -2 goes in all these spaces. And then you're going to use your PEMDAS rules. So parentheses, exponents, multiplication, division, subtraction. So -2 times -2 is positive 4. -2 times positive 2 is -4. And in this case, we have the answer is 4. So notice that I got a number to plug in and I spit out a number. So I input -2 and output 4. Let's look at g of 4 this time. I didn't leave myself enough space here, but g of 4, that means I'm going to find the function g. These are just the names. This is called function notation. And I'm going to input a 4 instead of an x. So g of 4 equals 3 times 4 minus 7. So notice that this is the number that they gave me right here, which is 12 minus 7, and the answer of g of 4 is equal to 5. Again, I input a number, I output a number. But what happens if I input an expression? So in this one, they want me to plug in h of x plus 2. Now, h of x plus 2 is a little bit harder than these problems, so I'm going to cheat first. And I want to show you what g of x plus 2 does, because this is an easier problem. They don't have anything to do with each other. I just wanted to show you. When I do x plus 2 here, I'm going to replace this x again. That's why I use a parentheses, because now I can replace it with whatever they want me to. So x plus 2, and then I would distribute in this case. So 3x plus 6 minus 7. Combine like terms. Remember, like terms have to have the same variable and the same exponent. So I only have one x to the power of 1. But I can combine these constants here, and 6 minus 7 is -1. So if they would have asked for g of x plus 2, I would have got out an expression. And notice that this has an x in it and some numbers. Don't freak out. That's fine. Don't combine them and say that the answer is 4 or something crazy, because that's witchcraft. But leave your answer 3x plus 1. Now let's go to this harder problem over here. X plus 2. When I plug it into this x squared here, I have to keep the x plus 2 together and put the squared on the outside, and then minus 5. Now this squared tells me that there are 2 copies of this parentheses right here. So I'm going to expand it by writing 2 of them. Now that I've done that, I can see that I need to FOIL these. So if you remember, FOIL is first times first, outside times outside, inside times inside, and last times last. And you can set it up like this, but I'm going to do it all together here. So we're going to do x times x to give us x squared. Outside would be x times 2, so plus 2x. Inside is 2 times x, so plus 2x. Oops. And then last is 2 times 2, which is 4. And then do not lose your 5. Just carry it along with us in the problem. Okay, So that's different than squaring each part, because notice I didn't get x squared plus 4 minus 5. I have a middle term here that you can't lose. Now I'm going to go ahead and combine like terms. So I'm going to combine my x's and combine my constants together, giving me x squared plus 4x minus 1. And I'm going to stop there. All my like terms are combined. I can't simplify anymore. That is the answer. Okay, so that's how you evaluate a function. If you need more help, reach out, ask for help.